In this video, we're going to take a look at 3 of the air conditioning schematics. Now, these are basic schematics that deal with motor operation. Remember, in air conditioning, one of the biggest things we're going to deal with through the entire term is motors. They move the air, they move the refrigerant, they cause a pressure differential on our refrigerant. So motors are used in every part of this operation, and we have to understand how to control them. Okay, let me pull this up a little bit so you can get a better idea of what's going on. Okay, the directions for this schematic, and this is a pictorial schematic, that says connect the terminals for proper operation. So we have a thermostat. It's a cooling thermostat, okay? It closes on a rise in temperature. That's this symbol over here. We have a capacitor. It's a run capacitor because that has a little dot and there's no other control devices. And we have our motor. One of the windings is 14 ohms. One of the windings is 5 ohms. So let's go ahead and take a look at the motor because we need to identify the start and the run terminals. The higher resistance is always going to be your start winding. So the type of motor is a permanent split capacitor or a PSC motor. Turn off spell correction. Our start winding is 14. Our run winding is 5. Okay, now let's get to good stuff. So we're going to connect the output of the thermostat, and I like as much as possible using straight lines. I'm going to connect the output of the thermostat to the capacitor. Okay. Now the dot on the capacitor, the side with the dot, should connect, if it's marked, to the run winding. So we're going to go ahead and connect that to the run winding. Okay, and that wire actually needs to go over there. Had it right the first time. The side without the dot connects to the start winding. And then common comes back to common. And then we can go ahead and label it if we want to L1. And let's call it L2. And we'll give it a 240 volt designation. Okay. So that's how this connects in. Okay. Thermostat calls for cooling. We energize the run winding, and we also energize the start winding through the run capacitor, and it's connected back to L2 for neutral. So the other thing we need to be able to do is we need to be able to take this into a ladder diagram. Okay, remember our pictorial is great for wiring. Okay, but the pictorial diagrams are not all that great for following sequence of operation. Now, I do have a pre-set up symbol sheet that I've drawn up, okay, that I'll copy some symbols from. So I'm going to come over here. Well, first of all, I made the start of my ladder grid, so let's just label this L1 and L2. Let's come over to my symbol sheet, and I am going to grab my PSC motor because I already have a PSC motor drawn. No sense in reinventing the wheel. So we're going to copy that. Okay, I'm going to go back to my schematic, and I'm going to move my PSC motor into the location where I want it at. Okay, so this symbol, here's my windings, run, common, and start. Run, common, and start. And my capacitor, my run cap, is already in my symbol. I drew these in advance. Okay, and again, it's not a bad thing if you do a lot of schematics to have a symbol sheet. So then I need to find my cooling thermostat, And I'm going to do the same thing. I have my cooling thermostat. I'm going to copy it. And I'm going to come over here, paste it in. Okay, there's my cooling thermostat. Now all I need to do is connect the two parts. And I have my complete circuit. And again, don't forget to label things. And we'll just label this motor. And I'm going to go ahead and label that as just RC for run cap. And we'll give it a voltage designation. Okay, so that is the schematic, the ladder diagram that matches the pictorial. Okay, sort of makes sense. Let's go on and do another one. Here we have three different components. Okay, well, two are the same. I still have my cooling thermostat, and now I have a potential relay, and I do not have a capacitor. So this motor is going to be induction start, induction run. It's a split phase motor. So what we're going to do is we're going to go ahead and wire this in. Okay, the same way as we did in the last one. Okay, so I'm going to come out of here. I'm going to go ahead and give it my line because I don't like skipping that. I'm going to come out of here to pin 1. Okay, because we always power potential relays with pin 1. Now, if this had a start capacitor in the way, I would be putting it in here someplace, but it doesn't. Pin 2 goes to my start winding. Pin 5 comes over here to common. And then I'll bring in a neutral. Actually, we'll just call this neutral as, or line 2 as well. Okay, now there's one winding we didn't power yet. Okay, so what I'm going to do is I'm going to bring this, let's bring the right wire over. I'm going to bring this wire over and I need to connect in my run winding because run winding gets constant power. Okay, let's go ahead and throw some labels on this just for the fun of it. I have my L1. I have my L2. We'll call it 240 volts. Okay, type of motor, split phase. Motor resistance of my run winding is 4. Okay, 14 on the start winding. 4 on the run winding. Now, the one last thing we need to do on this diagram is let's go ahead and do a ladder schematic because we have to be able to take any pictorial we draw and make it into a ladder schematic. So before I do anything else, I'm going to create my 2 rungs. Get it as straight as possible. I'm going to go ahead and label it L1 and L2. Might as well throw the voltage on it before I forget. Okay. Now, once again, I do have some pre-made schematics that I've drawn in the past. And again, if you drew a lot of schematics, I sort of urge you to do the same thing. Let's go ahead and grab my cooling thermostat. Going to come back over, grab my put my cooling thermostat in. Okay, that's a nice start. I have oh, we're going to go ahead and I'm going to grab my motor that I already have a potential relay on it. We'll have to make some adjustments. Okay, I'm going to come back over here. I'm going to throw my motor in. I'm going to remove the start cap. I'm going to remove the run cap because I don't have those in this diagram, right? If you look at the diagram above, there's no run capacitors. And we connect pin. We'll connect pin 1 up there. Just neaten this up a little bit. Throw some labels on it. Okay. So now we have, again, it's the same diagram basically, but the ladder schematic's very important because it allows us to see sequence of operation. Okay, when we look at this, the thermostat calls for cooling. It's going to close. It's going to energize the run winding of the motor, and because the normally closed contact pin 1 to 2 is closed, it's also going to provide power to the start winding. As the motor starts to spin, the start winding actually generates some voltage. It's called back EMF. That back EMF powers that relay coil, and at a certain level of voltage on that coil, it will open the contact between 1 and 2. And it will stop powering the start winding with line voltage. The start winding, though, because it's a coil of wire and there's a spinning magnet in that motor, it continues to power itself and provide power to that relay coil until the motor stops. When the motor stops, this contact will go back into its normal position, ready for the next run time. Potential relay, pins 1, 2, and 5. Okay, let's look at our third and final one of this video. Okay, we have a potential relay with a start cap. How do I know it's a start cap? There's no dot. And also, it's on the left side of the potential relay. So let's go ahead and wire this in. Okay, so I'm going to take my lines. I'm going to give myself my line 1, and I'm actually going to go ahead and do my neutral, or my line 2. That's a connection there. I know pin 5 has to connect to common. We're going to go ahead and put that wiring in. Okay, pin 2 we know connects to our start winding. Might as well put that in. Okay, our capacitor connects to pin 1, and our thermostat connects to our capacitor. Now we have one winding that doesn't have anything on it. Okay, unfortunately, this one's going to cause me to actually, we're going to end up jumping. okay, a wire here. So I'm just going to draw a jump in here. It's not the neatest thing in the world, but at least you can now see that we're jumping a wire. And I'm going to expand this one. And we'll come out from there and connect in there. Okay. So that's our pictorial. Let's go ahead and throw some labels on the wiring just so we know what we have. L1, L2, 240 volt. Okay, this is a start cap. Again, PR for potential relay, and we'll just call this motor. Okay, what type of motor is it? Capacitor start, induction run. So CSIR. What's my run cap resist or my run resistance? It's 5. What's my start resistance? 12. Okay. So that is my pictorial. Okay. And of course, we could label the thermostat as well. Don't want to forget about him. Okay. Now, since we know a pictorial, let's go ahead and draw a ladder real quick. And again, I do use some shapes and some symbols that I have on a symbol sheet. But let's start by drawing our ladder. The ladder got supports or the supply voltage lines. We always want to start with that, okay? Never forget about that. L1, L2. Let's go ahead and say what voltage we're using. Again, don't forget about it. Now, we're going to grab my cooling thermostat as I've been doing. Okay, because I do like starting with my thermostat. We start with the left side and work to the right. And if we have multiple rungs on the ladder, we do rung by rung. Okay, so let's pull my cooling thermostat in. Okay, now we have here again, we have a CSIR motor. So we have a start cap, a potential relay, and a motor. Since I have drawn this in advance, we're going to go ahead and grab this one. Okay, I'm going to copy that. I'm going to drag it back over here. And I do just have to make one adjustment on this. This has a run cap in it, which we'll get rid of. Okay, so I'm going to go ahead and get rid of the run cap. Okay, I'm going to connect the two together. And we're going to go ahead and label. Okay, so we have our thermostat that controls that provides power to the run winding. When the power is applied, we also provide voltage and current through the start capacitor, through pins 1 and 2, normally closed contact, to the start winding. As the motor starts to run, it starts creating what we call back EMF, which is additional power that can be measured between the start winding and common. Once that back EMF reaches a certain voltage level, that relay coil becomes energized with enough power and magnetism to open the contacts between 1 and 2, taking the start capacitor and the start winding out of the circuit. That start winding will continue to supply voltage to that start relay coil in the potential relay between pin 2 and 5 until the thermostat is opened. Once the thermostat's opened, the run winding gets de-energized, the motor will slow down to a stop, and normally closed contact between 1 and 2 will become closed again, ready for the next motor run. Take the time to study the lesser schematics, because as we go and as we add more and more components to an air conditioning system, the schematics get more complicated as time goes on. And it does not hurt, as you start adding diagrams, create yourself a symbol sheet that you can start adding symbols that you have for copying. If you're taking this in a classroom, please ask your instructor whether or not you're allowed to use a symbol sheet on any exams or anything. Most likely the answer is no.